So we started out originally by collating all the data that we get, which is essentially data that's produced on a transactional basis on every single policy that's written. Today, that data is aggregated because of the storage limitation and compute limitation. The transactional data is aggregated at the portfolio level, and we use that aggregated data for processing. But as you can realize, we would rather want to use the real transactional data to calculate the exposure, right? So the volume of data that we're talking about here is hundreds of billions of records and tens of terabytes of information that we have to crunch, aggregate, we have to calculate the measures across various dimensions. So we started with our Hadoop infrastructure using what I guess most of the businesses use, which is trying to aggregate that data and trying to do OLAP on top of Hive. Obviously, we've run into limitations with that approach with performance from a performance and scalability standpoint. So that's where I guess we looked at Kaivo's.
Right. So I think when we visited you, one of the things you were struggling with was the amount of time it would take to get the jobs created on Hive and run on Hive to get you talked about reducing the time taken to process the data from weeks to days or potentially a day.
Right.
But you wanted even faster, more interactive ability to be able to get to the data and get it immediately.
Right. So from a business standpoint, it's all about being able to analyze the data in real time, right? So if I'm, as an underwriter, I'm issuing a new policy, then I need to understand what's the risk and be able to price that risk. So at any given point in time, I need to understand what my exposure is across various sorts of dimensions, right? It could be a geographic location, it could be the type of company or the business or the industry type that we issue policies in. So the point is, from a business standpoint, they need the answers in real time. They need the analytics to be done in real time. From a technology standpoint, there has always been a gap in terms of the volume of data that we could handle, in terms of the compute that we could do with data. With the Hive-based approach, we tried to address the storage issue. In certain respects, we tried to address the compute issue, but getting to that real-time querying is always been a challenge with that approach.
So we worked with you and we put a proof of concept in place.
Yeah.
And anything you have to say about what
Sure.
Results you got from there, or?
Yeah, so we started on a POC with Kaivo's, I would say towards the beginning of this year. The total duration of the POC was, I would say, probably 3 to 4 weeks. It was fairly quick. We took a sliver of data. Of course, we didn't take all our 30-40 terabytes of data, but we started with 5 terabytes of data as our initial data volume for our risk as well as event data. And then the cube that was built on that 5 terabytes of data was in under 20 minutes with the infrastructure that we had. We followed that up with adding increments to that data, which was about half a terabytes of increment. And that took about 15 minutes or so to augment to the cube that was originally built with the 5 terabytes data. In terms of performance, with that amount of data, we were pretty happy. If we are able to calculate the cube and then incrementally add additional data and adjust the cube based on the increments coming through, then that basically addresses our business problem.
Great.
Thanks.
So that's one of the use cases. I described a couple of others. Entervision, which is a media company that's looking for analyzing consumer behavior across the Latino market. They had about 15 million users that they wanted to understand the transactions and understand what people were actually doing. So they were moving from kind of a sample and survey-based approach where people would self-report on what they viewed and so forth into an environment where you could actually get empirical data on what they were really doing. So getting this level of information recorded and analyzed, combining transactional data, purchase behavior, demographic information, and so forth. So now their customers, which are people that do media campaigns and so forth, are now able to measure the return on their campaigns with much more preciseness and prove the efficiencies of those campaigns much more than they could do in the past. So they're getting immediate results on the ROI. We talked about the telecom subscriber profiling use case I talked about in some detail before. We're seeing, we talked about risk analysis, operational analytics, people that are accessing data or software on a site and downloading it across the world. This is when a new release comes out. These people are looking at analyzing, where are their bottlenecks? Are people getting the satisfaction they need in terms of getting the quick downloads and upgrades? We've got a use case in the travel industry, analyzing shopping data. I described that a little bit in the example. Set-top box analysis data for viewing, tracking how customers are, which channels they're viewing, where they're spending time, how they're switching between channels, and so forth. So now you can, get data. These are typical big data use cases, but thinking about them with the OLAP view, you can see how you can get a lot more value from that data versus running an algorithm and kind of going away and coming back hours later to get some results. In addition to that, now you can actually explore and look at different aspects of the data and put it in the hands of the business user that really is trying to get value out of it. So that's pretty much what I had for the presentation. If you guys have more questions, we can address them now, or stop by at our booth, S5, and we can answer more questions. Yep.
Your OLAP data feed format, is that proprietary?
Yeah, so what we expose, it's a standard interface, right? So how we store it, with the compression and everything, yeah, that is where we spent, our IP. But the interfaces are standard, MDX. Yep.
So the data storage have anything to do Hadoop or can be anywhere? Why it should be Hadoop? I know that there's a translation you make.
Right. But yeah, so the reason is because for most companies, Hadoop is becoming the data lake. So that's where your data is. And what we're saying is you don't have to move it out somewhere else. You can, keep the data right there, keep copies of the cube right there, and do your analytics right there. Yep.
The question is not particularly Hadoop.
Sure. This, the algorithm could be applied on any distributed system. It doesn't have to be Hadoop. But Hadoop gives you the, cost-effective scalability, compute, and storage. Yeah.
Your engine is part of the Hadoop system, or have you installed separately as a client somewhere to interact with this?
Yeah. So like I said, the Kairos engine would run on an edge node on the Hadoop cluster because that's where you're submitting your jobs to the Hadoop cluster. The query nodes would run on the data nodes. The query servers would run on the data nodes as yarn processes. Okay. Yeah, go ahead.
How do you expose the data lineage? So you have multiple sources and then you have aggregation. One of the problems with traditional OLAP is to track the data down. Do you have any tools or statistics to help with that?
I'm not sure I totally got the question.
Data lineage.
Data lineage. Yeah, so this doesn't really, this is not so much on the governance side in terms of tracking lineage and so forth, but you can keep track of, basically, timestamps and so forth, as new data comes in. So.
But I'm referring to if I have an aggregation in my queue, I don't know where that aggregation came from.
Oh. I'm not sure if we give you a direct way of going back and taking when you're computing the aggregations or calculated measures and so forth, you're specifying what's happening there. But in terms of kind of tracking back on the lineage of exactly how those aggregations work, we don't make that, we don't expose that today. If that's an issue, if that's a requirement, we can look into how to do that. Yeah.
That will help with data dictionary reporting.
Okay. All right. Sounds good. All right. Thank you all.